we will discuss about this problem. Here you have to find out the Z parameter of this network. Now, how to calculate this Z parameter of this network? Here you see this portion are in delta form. So it will be easy to calculate Z parameter if you transform this delta form into a star or T form. Okay, so you can transfer it into a T form. That means there must be a resistance and there must be a resistance and there must be a resistance, and this is the one port and this is another port, and this resistance is 6 ohm and this resistance is 10 ohm. Okay, so there must be a one impedance and there must be another impedance and another impedance. So this delta form must be transformed into a star form, okay, T form. Then it will be easy to calculate the Z parameter of this network. So first of all, we will transform the delta form into this T form. Now suppose this is A, this is B and this is C. So there must be a resistance and there must be a resistance and there must be a resistance. Okay, it is called R12, it is called R13, it is called R23. If you transform it into a T form, this is A, this is B, this is C. This is called RA, this is called RB and this is called RC. So if you transfer this, then RA is given by this, multiply this resistance R12 into R13 divided by sum of these three resistance, that means R12 plus R13 plus R123, and RB is given by the, this is B, so the multiplication of these two resistance, so it will be R12 into R23 divided by the summation of this resistance. And similarly RC is given by the multiplication of these two resistance, so it is R13 into R23 divided by summation of these three resistance. This is the formula for transferring a delta form into a T form or star form. Okay, now in this network, suppose this is terminal A, this is A terminal and this is B terminal and this is C terminal. So this is a resistance, this is a resistance, this resistance is 4 minus J5, this is R, this is R12, this is called R12, okay, and this is called, this is J5, so it is C, so it is called R13, this is called R13, okay, and this is called R23. Okay, now if I put this value in this formula, then I will be able to calculate the value of RA, RB and RC. This is the RA, this is RB and this is RC. Okay, so here RA, R12, that means R12, this means this resistance 4 minus J5, 4 minus J5 multiplied by R13, this is 13, so this is J5, and the summation of all resistance, so this is 4 minus J5 plus R13 is J5 plus R23 is 5. So in this case it will be 25, so plus it is 20 J and minus and J square is equals to minus 1, so it will be 25. So 25 plus 20 J. If I multiply this into this, it will be 25, and this into this, it will be plus 20 J, and this is cancel out, so it is 9. So it will be 9, it will be 2.25 divided by 9, so it will be 2.77 plus 2.77 plus 2.22 J. So it will be 2.77 plus 2.22 J. Now similarly you put this value here, R12 is 4 minus J5 multiplied by R23 only 5, and if you sum this resistance, all the resistance, so it will be 9, so here it will be 20 minus 25 J and it will be 9, so here it will be 2.22 minus 2.77 J, and if you multiply it here 13, this is 13, so J5 multiplied by only 5, and here 4 minus J5 plus J5 plus 5, so it will be 25J divided by 9, so it will be 2.77J. So here it is 2.77 plus 2.22J, and RC is 2.77J, and RB is 2.22 minus 2.77J. This is the V1 and this is V2. Okay, this is V1, this is V2, and here this is current I1, this is current I2, and here this is current I1, this is current I2 for two-port network. So here I transfer this network into a T form by using delta to T transform. Now from this input portion, from this loop, and from this output, that is port number 2, this is port number 1, this is port number 2, this is I1. So from this branch there will be I1 plus I2. So if I take a KVL in this loop, port number 1, so here V1 is given by I1 into 2.77 plus 2.22 J plus this is I1 plus 2.77 into I1 plus I2. This is the KVL equation of this port number 1. So here this is I1 and this is I1. If I apply this there, this is 10, there must be a 10, this is 6, so here there is another 6, so it will be plus 6I1. So this is 6I1 plus 2.77 plus 2.22 J plus this, so it will be, this is I and this is and this is, so here it will be I1 into 2.77 plus 2.22 J plus this is 2.J, okay, so plus 2.77 J plus 6 plus 2.77 J into I2. So from this equation it will be 6 plus this, so it will be I1 into 8.77 plus 9.4 J, and here it will be 2.77 J into I2. So this is equation number 1. So this is V1. Now using this loop port 2, we can write that V2 is given by, this is 10 ohm, so 10 into I2 plus 2.22 minus 2.77 J into I2 plus 2.77 J into I1 plus I2. So here I1, only I1 is I1 into 2.77 J plus I2 is, this is capital letter I2 into, it will be, there will be 10 and it is plus 2.22 minus 2.77 J, and is there is another J plus 2.77 J, okay, this is I2. So it will be I1 into 2.77 J plus I2 into, this will be 12.22 and this will be cancel out. So this is the equation of V1 and this is the equation of V2. Now if I write this two-port network in terms of Z parameter, then it will be V1 equals to Z11 I1 plus Z12 I2, and V2 will be Z21 I1 plus Z22 I2. So if I compare this two equation 1 and 2 with this equation number 3, then we can write that Z11 is equals to Z11 is equals to this 8.77 plus 4.99 J, okay, and Z12 is given by this, so it will be 2.77 J, and Z 21, this is 21, okay, so it will be 2.77 J, and Z22 is given by this, it will be 10.22. so in terms of matrix form, this will be the Z matrix will be 8.77 plus 4.99 J, and here will be 2.77 J, and here will be 2.77 J, and here will be 10.22. so in this way you can calculate the Z parameter for this type of network.